In this video, we will understand the operations of NameNode daemon. Each Hadoop cluster has a NameNode. The NameNode holds all the metadata in memory for fast access, but also persists the same information to disk. The following information is stored by the NameNode on disk in the FSMH file. The followings are the name of all the files in HDFS, the HDFS directory structure, the file permissions of the file in HDFS. The namespace contains the directory and files instead in a hierarchical function. Each namespace has a unique namespace ID that's stored on all the cluster nodes in order to prevent data nodes with a different namespace ID from accidentally joining the wrong cluster. Anytime there's a change in the metadata due to operations such as file creation or deletion, it does prompt the immediate revision of the file FSMH file. Instead, the change information is recorded in the edit files on disk. By default, every hour, the secondary NameNode merges the edits and FSMH files and writes the consolidated information as a fresh FSMH file. The NameNode truncates the old edit file at this point and starts writing new stuffs to it. This figure shows how the NameNode relates to the data nodes as well as how HDFS clients communicate with the NameNode and the data nodes when HDFS clients wants to write or read files stored on the data nodes. They contact the NameNode which has the file metadata. The NameNode uses the HDFS metadata to determine which data node is storing the data blocks for the HDFS file users Shri directory1 file1.txt file. The data files are made of blocks and data is replicated. By default, there are 3 copies for each data block. The only reason the NameNode keeps the HDFS metadata in RAM is for easily accessing the data when clients require access to HDFS data. A client can't access the data nodes directly. Clients don't have any idea which data node might be hosting the data that they need. Clients access the NameNode instead, which act as the intermediary between the clients and the data nodes. The NameNode passes along to the client information such as the file block numbers and data locations. Initially, file metadata is stored in the FSMH file on disk. When the metadata changes due to actions such as file creation or deletion, the change information is returned to the transaction log on disk named edits. It is the secondary NameNode who does checkpointing for NameNode daemon. When a client application writes data to an HDFS file, the NameNode updates the HDFS metadata in RAM, and the changes are also returned simultaneously to the edits file. The reason the changes are written out to the edits file is to preserve the modification to the namespace. If the NameNode crashes, the information stored in RAM is lost. If your cluster's NameNode ceases functioning for any reason, HDFS becomes unavailable to you and the applications that are running. You must restore the NameNode in order to make HDFS available in the users again. Of course, if you are using a standby NameNode, the loss of the active NameNode will bring up the standby NameNode automatically. In such a setup, losing the server on which the NameNode is running really won't affect anything, since the cluster will function uninterrupted in every way. In order for a map process from a mapreduce job to read data from HDFS, it first contacts the NameNode. The NameNode will send the map client the block names and locations, that's a data node, for the first few blocks in the file. Similarly, the reduce process that writes its result to HDFS will contact the NameNode, which will then supply the block names and the locations of the data nodes where the reducer process should write its file. It's thus the NameNode that determines where the client writes. By sending it a list of approved data nodes to which the client should write. The name node itself never sees any of the data. It acts as the facilitator for the actual data access by the client on the data node, where the data is stored. As you can see, both the read and write processes initiate their work by first touching base with the name node. Hence, unavailability of the name node means that the cluster is basically unavailable. While the secondary name node performs the housekeeping duties such as periodically checkpointing the FS image, it by no means can set in when the name node becomes unavailable. You need to set up a standby name node for that purpose. Here we have completed and we have seen the different operation which NameNode performs in its day-to-day activities. If you like this presentation video, please hit the like button, write your comments in the comment box, share this video with others and subscribe our channel. For watching this video, thank you very much.